right? It is 4 years of problem solving and calculation from definitions. It's basically an applied math major, only we have a very particular choice of applied problems, whereas people who call themselves applied mathematicians have a somewhat wider range of problems that they like. But here, this is clearly, if you just take the derivative, the acceleration is proportional to the square of the velocity, not to the velocity. Other questions? Anybody has a question? That's all I've got for now. Oh, actually, I do have one more problem. I do have one more problem. I just remembered one. By the way, I'm not going to figure out how to export all this stuff, but if someone else wants to figure out how to export all of this.
That's the end of the screen.
2 fingers. 2 fingers.
Oh, that's the end.
Oh, I think I've run out of memory. I think that's the issue. Okay, I see. So, really, that's all the memory this thing has? This thing doesn't have any more memory than that? Okay, then we're going to have to lose something. We're going to lose the projectiles. Yeah, there's got to be an easier way to do this. Don't make me do things the hard way, because the hard way is like, ew. No, I can't erase them.
Double tap it?
What?
Whoa.
That was weird.
Maybe just go back and start moving. Start moving.
I don't want to erase everything. Oh, I can save it. Okay.
Delete some other people's stuff.
Just delete some other.
One of them is this one.
Yeah.
Okay, so now I'm going to try to.
Press it, don't hold it down.
The classic.
Okay, was there?
February 14th.
Okay.
Okay.
So, wait, did I like delete what I had before?
No, it's
Okay.
okay.
Okay, so I'm gonna save this, I'm gonna add a new one here. Okay, so what was the problem I had? Oh yeah, so we've got a planet of mass m, and it is spinning at a rate omega, and someone is standing on the equator, and they are standing still with respect to the planet. So you tell me which term or terms in that formula for acceleration in a non-inertial frame will we have to deal with? Centrifugal, Coriolis, both, neither? Well, the Coriolis force is, it is 2m v cross omega. So if the person is standing still with respect to the planet, you tell me what's v. So why do we have to deal with the Coriolis force again? See, why do you guys do this thing? Why do you say, I ask which terms are going to matter, and then you just start tossing out things that are zero? Think about it. Don't just guess. Think about it. All right. So somebody's standing on the equator, and this planet is spinning, and I want to know, we know that if somebody's standing at the equator, because of the centrifugal force, the Earth's the apparent force of gravity feels a little bit weaker, right? We learned that last week. As we keep spinning the planet faster, the force of gravity is going to feel weaker and weaker. And what I want to know is how fast should it spin before they don't feel any gravitational force. So, by the way, let's just cross out this. This is irrelevant. And you can assume that the mass and radius of the planet are given. None of the problems are going to be exactly verbatim from this, but all of these are practicing concepts similar to problems that will be on there. Right? Only the centrifugal term matters. Okay, so omega cross R is going to point into the board. Then we take a vector into the board and cross it with omega. We're going to get something that points to the right. And so this is going to be the direction of the centrifugal force. And when the apparent gravity is 0, that means that the centrifugal term is exactly equal to mg, right? Okay, so let's see. In this triple cross product here, what were all of the angles between vectors when we took the cross products? 90. So all the sine theta factors were just 1. So looks like it's going to be that the magnitude of the centrifugal force is just m omega squared r, right? And that is equal to mg, or little m times big, I have no idea why little m, why half of the letters are coming out red. Right? Anybody disagree with what I just wrote there? So we're going to get that omega squared r is mg over r squared, or omega squared is m over r cubed g. By the way, does this depend on the size of the planet?
Yes.
Oh, it does. Just the position.
Just your radius, just your standing radius.
Looks to me like it depends on the density. If I had another planet made out of the same, with the same composition, only a different radius, so same composition means same average density, then I would have the exact same value of omega. Right?
So it still depends on the radius.
It's G.
The planet had uniform density then. I mean, obviously, if we added, say, just more of the outer material or more of the inner material, if it's non-uniform density, we're gonna get different results.
How non-uniform is the Earth?
Ask a geologist. I mean, I know that the interior is mostly iron, but I don't know a lot more than that. I don't know how the interior density, I don't know the density profile is the bottom line.